Today I'm going to talk about a very special application of the difference quotient. You were introduced to the difference quotient. There was a little interruption there, sorry about that. But this is called the difference quotient, f of x plus h minus f of x all over h. It's a very important formula that we're going to be using probably for the rest of this year. So it's something that you have to be familiar with and something that you're going to have to be able to use on different functions. So what I'm going to do in this video is I'm going to go through a few functions and show you exactly how to calculate this. And in the end, we're actually going to find limits. We're going to use the limit process on this different quotient. But I'll show you that in the end. So let's do some examples. I think the best way to go through these are some examples, and I'll start with some simple examples first. Let's say f of x is equal to 7x. So what we're going to do is we're going to set up a chart, and this chart will have 3 different columns. So here's the given f of x. And then what we're going to do is we're going to have an f of x plus h column. Whoops, let me just put the example. Here's an f of x column, and our f of x example is going to be 7x. And then on our next column, we're going to do f of x plus h, and then we're going to simplify that down. And then in our next column, we're going to figure out what is f of x plus h, this second column, minus f of x, what's in this first column, and divide the whole thing by h. And then, in the end, we're going to take the limit, or we're going to substitute h equals 0, and see what that gives us. If h is equal to 0, what will this third column become? So let's start with this example number 1. Let's say f of x equals 7x. Well, f of x plus h, you're just substituting x plus h in for that x, and it's 7 times x plus h, which is equal to 7x plus 7h. The next column, if I want to do f of x plus h minus f of x, I do the second column minus the first column, which is 7x plus 7h, that term, minus 7x. And we're going to divide this whole thing by h. So you can see that you can clean up the numerator by adding 7x to negative 7x. And what we're going to get is 7h divided by h, which is just equal to 7. And if h is equal to 0, well, it really doesn't matter because those h's disappeared. So if h is equal to 7 or 0, then the whole f of x plus h minus f of x all over h is equal to 7. And that is our first example. Example number 2, let's say f of x is equal to negative 2x plus 9. F of x plus h is negative 2 times x plus h plus 9. Just substitute an x with an x plus h. And that gives us negative 2x minus 2h plus 9. So now we're going to do the second column minus the first column. Negative 2x minus 2h plus 9 minus the first column in parentheses, negative 2x plus 9. All over h. So what we have is negative 2x minus a negative 2x. They'll cancel out because that'll be negative 2x plus 2x. We have a positive 9 minus a positive 9, so those 9s are going to disappear. And what we're going to be left with is negative 2h all over h. Well, the h's are canceled out, so if h is equal to 0, it doesn't matter. They canceled out. So the answer would be negative 2 if h equals 0. Now, it's not always going to be like this, and you'll see sometimes we do end up with h's that we'll have to substitute in. But these first two we didn't. And you'll see with this example number 3, what if f of x is equal to x squared? Well, f of x plus h is x plus h squared. That's a FOIL, x plus h times x plus h. And you should be able to start to quickly do this. This is x squared plus double the product, x h plus the last squared. Now in the third column, we're going to do the second column minus the first column, f of x plus h minus f of x. So that becomes x squared plus 2xh plus h squared minus the first column all over h. And the x squareds will cancel out. One of these h's will cancel out because you have a GCF here. You can pull an h out of that and you're left with 2x plus h. And then this h will cancel with that h, and you're going to be left with just 2x plus h as your second column or your third column. And then if h equals 0, you're going to substitute a 0 in, and you're going to be left with 2x. And that's the end of that example. Example number 4. What if you have x squared plus 4x as your function? Well, what we have with x plus h, f of x plus h, we have x plus h squared plus 4 times x plus h. Well, we have to clean this up a little bit. We have to FOIL like we did before, and we get x squared plus 2xh plus h squared. And then we have to add to that 4x plus 4h. And my column is a little bit too narrow. If you combine like terms, let's see, do we have any like terms? I don't think we do. We have an x squared, we have an xh, we have an h squared, we just have a 4x and a 4h. So there are no like terms here to combine at all. Now we're going to do the second column minus the first column, all divided by h. So it becomes what we just wrote there, x squared plus 2xh plus h squared plus 4x plus 4h minus f of x, which is x squared plus 4x in parentheses, because you've got to negate both of those, all divided by h. The x squared minus the x squared goes away. The positive 4x and the negative 4x go away. So what we're left with is 3 terms. They each have an h in them, so we can factor out the h, or we can just cancel one of these h's with this denominator. And what we would be left with is 2x, that h canceled out, plus h, one of those h's canceled out, plus 4, that h canceled out with the denominator. So here is the f of x plus h minus f of x all over h simplified. And then when you substitute h equals 0, you're going to get 2x plus 4. And that's the end of that problem. The next example, number 5. What if we have f of x is equal to x to the third power? Well, this is when we have to use a little bit of algebra 2, binomial expansion, because f of x plus h is x plus h to the third power. What you can do is you can multiply x plus h times x plus h times x plus h if you wanted to do it the long way. Or if you remember binomial expansion, you have a Pascal's triangle. If you remember the Pascal's triangle, I'll put it over here. 1, 1, 1, 1, 2, 1, and 1, 3, 3, 1. If you want to raise a binomial to the third power, you're going to use the third row of Pascal's triangle, which is 1, 3, 3, 1. You're going to take the first term, which is x. You're going to raise it to the third, second, first, and 0 power. You're going to take the second term, which is h. You're going to raise it to the 0, 1, 2, and 3 power. And because this is a sum, you're going to add those terms together. There are no like terms here. It's going to be 4 terms in your answer. So x plus h, f of x plus h turns out to be 1 times x cubed times 1 plus 3 times x squared times h plus 3 times x times h squared plus 1 times h cubed. So there's f of x plus h. It's got 4 terms in it. If this were to the 4th power, it would have 5 terms in it. And now we're going to take the second column minus the first column, so that becomes x cubed plus 3x squared h plus 3xh squared plus h cubed, and now we're going to subtract out that first column, which is an x cubed, all over h. What happens is the x cubes are going to cancel out. You're going to have one of these h's cancel out with the denominator, and you're going to have 3x squared, that h canceled, plus 3xh plus h squared. And then in the 4th column, you're going to substitute h equals 0, so you have 3x squared plus 0, which is just 3x squared. And that's the end of that problem. And here's a very complicated one. Let's say f of x is equal to x to the 3rd minus x squared plus 1. It looks pretty innocent. But now, when you want to find f of x plus h, you're going to substitute x plus h to the 3rd power minus x plus h to the 2nd power plus 1. Good thing I didn't put an x in there, because you would have had another x plus h. And that looks pretty innocent. But if you remember, if you can keep the x plus h cubed around somewhere so you don't have to redo that one every time, you can remember from the past example that this is x to the 3rd plus 3x squared h plus 3xh squared plus h cubed. That's the cubic one. Now you have to subtract out, with this minus, x plus h squared. Well, we did that a couple times, and that's x squared plus 2xh plus h squared. And then you have to tack on a plus 1 in the end. So there's your second column. That is a really long one. And what I think I'm going to do on this example is, instead of rewriting this all over again for the 3rd column, I'm going to just take f of x plus h, subtract out the first column. So I'm going to say minus f of x, which is x cubed minus x squared plus 1. And then I'm going to divide this whole thing by h, so I can get this, combine the 2nd and 3rd column together without having to rewrite a lot of stuff. And then in the end, the 4th column, we have to substitute h equals 0 in the end. So what we have is, we have an x cubed here and a negative x cubed here. We have a negative x squared here and a minus a negative x squared here. A negative x squared with a minus a negative x squared cancels out. And then we have a negative 1 here and a positive 1 here. So this positive 1 cancels out with this minus 1 here. And you'll notice that the f of x terms will always totally cancel out with terms over here in this f of x plus h column after you get done with a lot of practice on this. So now what we have is a whole bunch of terms, and they all have h's in them. So because they all have h's in them, we're going to just cancel out one of those h's with this h in the denominator. And so what this becomes is, this first one becomes 3x squared, that h went away, plus 3xh, one of those h's went away, plus h squared, one of those h's went away. Now we're going to subtract out 2x. Well, that h canceled, so we're just left with 2x. Now we're going to subtract out this minus. One of those h's canceled out, and then everything else is gone. So this is the result of f of x plus h minus f of x all over h. And now in this last column, when h is equal to 0, what happens? This term goes to 0, this term goes to 0, and this term goes to 0. So we're left with 3x squared minus 2x. And that's the end of that problem. I want you to try one on your own. So I'm going to give you, I guess, one that's more complicated than anything else, and we can go over that one in class tomorrow when you get here. So let's say f of x is equal to 2x cubed plus 2x squared minus x. Now that's going to expand out to be a very long second column, and then you're going to subtract this out and then cancel out with an h. So you try this one on your own, and then we'll go through this one and some others in class tomorrow. Have a great evening.